All right, Paulameena.
Yep, it's my turn. Okay, so I liked how the Cooper Lab did a little bit of their like personal academic background. So it's not on the slide, but I'll start with that. So I'm now a fifth year MD PhD candidate and I matriculated in 2021. Before that, I actually did my undergraduate in the Bay Area at UC Berkeley. And I was a bioengineer by training until I joined the lab of Stephen Brunner, who does computational genomics and like SNP prioritization type things for rare diseases. And I kind of fell onto a computational quantitative route a little bit later than Jeff suggested it happened. I thought I was going to be a wet lab scientist through high school and the first 2 years of college and then ended up double majoring in computer science by the end of year four. Um, Coming to Cleveland, I found obviously Jake's lab, where the perspective on why medicine stops working, right? Like why resistance happens and the evolutionary perspective really spoke to me. And that's kind of what pulled me into the lab. But what was interesting is when I first joined the lab, some background on my specific project, one of the postdocs at the time, Dag, who has since left for Oslo, he was doing some of the game theory assays and he noticed some spontaneous cell fusion of his green and red tagged cells. These were PC9 cells that, when left to their own devices for 40 plus days, will fuse at very, very low levels, like 1 to 2%. But if you apply a selective pressure, like a drug, the fused cells are selected for. And as the parental cell population dies, that niche is kind of filled by a mix of the resistant and fused cells. So he actually saw up to 40% fusion after this application of drug, which was really nifty and not something I was aware that cancer cells could do. And so that's kind of what spun off my whole project is this kind of lots of questions around fusion, but why does it happen? What does it do in a cancer context? And is there genomic signatures that we can trace, and can we look for that in other cancers?
So